So, extreme value theorem, it has to do with finding absolute maximum and minimum points. An absolute maximum or minimum point would be your highest or lowest point on the entire function for the given domain. So, absolute maximum and minimums are going to be your very highest or your very lowest point. Okay? So, if f of c is the absolute minimum of f on the interval I, then we're going to say that f of c is less than or equal to f of x for all x in I. So, if it's absolute, right, everything is higher than that point. Now, it can occur more than once. Like, you could have a function that looks like this, like a W sort of function, where, I realize these two aren't perfect right here, where these 2 points are at the lowest point. So you could have it happen, but your maximum or minimum value is your Y value, so that minimum value would still be the lowest value on the graph. So like if this is at 4, right, if that on our graph is at 4, then your absolute minimum would be 4. There. If C is the absolute maximum of f on the interval I, then we would say f of C is greater than or equal to f of x for all x in I. I think I've forgotten the word that goes in that next blank. No, relative or local. I might have to check my completed notes here. I think it maybe global. That sounds. Typically, absolute maximum are usually referred to. Yeah, global. Okay, I had it right. I was not so sure about it. Absolute maximums and minimums are also sometimes called global maximums or minimums or extrema. So the word extrema is a word that we can use that includes both maximums and minimums. So you might see extrema used instead of maximum or minimum. It just means that they cover both things with that word. Global is looking at the whole entire function, or the whole entire, it's looking at whether or not it's the highest on the entire interval. Rather than, we'll look tomorrow at local or relative maximums and minimums. Relative would be like if you have something like this. This point right here is not the lowest point on the graph, but it is lower than the other points around it. That's what we would call a relative or a local minimum versus having something like this where you have, the very lowest point on the graph. So that's sort of where we're going with that. So, relative maximum min is higher than the points around it, a point where the graph switches from increasing to decreasing or vice versa. If there, that's not worded right. Sorry, I should have looked back through these notes. I didn't realize they were in such a mess. I need to fix things. Okay. That shouldn't say and. if there is any open interval containing C on which f of C is a maximum or minimum, then f is called a local or relative maximum or minimum. So just to look at this real quick, if I have this graph right here for a relative maximum or minimum, if we look at like this point right here, if I have an open interval, so from like, I could say from -2 to 0, I have a maximum point from -2 to 0, right? But is that point right there the maximum of the whole entire graph? It is not, because you've got higher points over here, right? And if I look at an interval, say even from like -2 to 4, right? This is my lowest point from -2 to 4, or from 0 to 4, or 2 to 3.5, right? So it's not a certain interval, but there is an interval somewhere where this is my lowest point. So that is called a relative minimum, but it is not the absolute minimum because I've got points lower over here. Okay, so all right, so let's look at this graph right here. We're supposed to find all maximums and minimums, both absolute and relative. So for this particular graph, you've only got one. Okay, what do we have here? We have an absolute or a global, try to use both words, minimum. And so here is, I want to be real clear, the minimum value is your y value. So what is the absolute or global minimum here? It is -4. So this right here, you're given the y value. A lot of times you will want to say that it occurs at x equals 3. In fact, sometimes they'll only ask you for the x coordinate where it occurs. They won't ask you for the actual minimum. But it occurs at x equals 3. But that minimum is the y value. Okay, now, I will say all absolute minimums, if you're looking at the entire graph, are also relative minimums, right? Because if you have if you were looking on the entire domain of the graph, this also meets the requirement to be relative, but absolute is more precise in this case. Is there a maximum? If we're looking at the entire domain, these both increase to infinity, so there is no maximum because infinity cannot be a maximum. Okay, all right, for this one, okay, we'll have to estimate a little bit for this. First of all, do I have any absolute maximum or minimums for this graph? I do not, because this graph continues on down to infinity. On that left-hand side, it continues on up to positive infinity on the right-hand side. So you do not have absolute maximum minimums. For my relative or local maximum, what is my relative or local maximum? And you may have to estimate a little bit. It would happen right here. And which coordinate is our maximum? The y. So y coordinate there is probably 35, we're estimating a little bit here. We could say that it occurs at x equals, that looks like it's probably 3, -3. But the maximum value is 35. And then for our relative or local minimum, that would happen right here. What do you guys think for the y coordinate there? I think it's probably 3. And it occurs at x equals, looks like that's probably x equals 1. Okay? All right, now, let's look at this graph. This graph is different than the last two that we looked at, because the last two that we looked at had arrows that went up and down forever, right? This one does not. This one, oops, has endpoints. Okay? So, if I'm looking for the maximums and minimum values, what would I have for this? Do I have absolute on this? A value that's higher than every other value, a value that's lower than every other value? I do, right? So these are going to be absolute maximum minimums that you can find. So my absolute or global, let's do minimum first. Okay? That global minimum, the very lowest point on the graph, that happens right here. What is that minimum? It is -4. And we could say this occurs at x equals 3. And sometimes that number will be important. They'll ask us for that x coordinate also. But if it just asks for minimum, you're given the y value. And then our absolute maximum, what's our highest point here? It is 12. So our absolute, yeah, that's fine. Yeah, that's fine. Okay, so our absolute or global maximum is right here. It is 12. It occurs at x equals 7. Now, this looks like it's probably a quadratic, right? Probably. So, if this was a quadratic and I had arrows on the end, would it have a maximum? If these endpoints, like if, instead of having dots here, if these went on forever, would I have an absolute maximum? I would not. But whenever I cut it off, or I'm only looking at a specific interval, then I'm going to have absolute maximums or minimums, right? So, extreme value theorem tells us that. So, if f is continuous on a closed interval from a to b, then f has both a minimum and a maximum on that interval. So if you have a continuous function and you're looking at a closed interval, so we are looking at this from -7 to 2, or 0 to 15, right? If there is a specific interval we're looking at and we know that our function is continuous, there has to be an absolute maximum, there has to be an absolute minimum. It is possible, like the most simple possible scenario is that you've got this, right? You have a horizontal line. So we got a horizontal line, we got our endpoints. Does that have a maximum? Let's say this is it has a maximum. The maximum is 3. That's the highest it ever goes is 3, right? 3 is greater than or equal to the value forever. Does it have a minimum? It does. Also 3, right? So if it's continuous and a closed interval, then you're going to have a maximum or a minimum. They're not going to ask you about this very often, a horizontal line, because it's not a very interesting problem, right? More than likely, what you're going to see is you got a function, and it does who knows what, you know, something like this, right? If it is continuous and it is on a closed interval, it has to have an absolute maximum and absolute minimum. It might be, it may look many different ways, but it has to have absolute maximum, absolute minimum. Okay? All right, so critical numbers are something that's going to be really important in the next few sections that we look at. Connor, why don't we shut that computer, please? Pretty please, thank you. And these are going to be points where the derivative of the function is equal to 0 or is undefined. Okay? So, critical numbers are going to be really important because for critical numbers, if I know my derivative is 0, that means my equation of my tangent line, or my slope of my tangent line is 0, right? So, like, if I look at tangent lines right here, they have a slope of 0. What do you notice about all those places that I have tangent lines of 0? We see that those are maximum minimum points, right? So critical numbers are going to be places where you possibly have maximum or minimum points. So if we are asked to find the critical numbers for each function, it is places where our derivative is either 0 or undefined. So if we have something like example 4, we would first need to find the derivative, right? Whenever I find the derivative, let's see, Wesley, what do we get for the derivative for example 4? Very good. All right, then we would want to see where that derivative equals 0 or is undefined. Is that ever going to be undefined? It is not. Undefined would be either negatives under square roots, zeros in the denominator fraction, or negatives under square root, or not square root, I already said that, natural logs. But typically, fractions. We don't have fractions here. So we're just going to take this, 9x squared minus 4x, set it equal to 0. How do I solve that? Factor out an x. So I got 9x minus 4 equals 0. So then each one is set equal to 0. I'll get x equals 0. I'll do 9x minus 4 equals 0. So x equals 0 is a critical point. And then I'll get x equals 4/9 is also a critical point. Okay, so if you're asked for critical numbers, you're just going to take the derivative, set it equal to 0. When you do the same thing for 5, it's a little tougher because our equation's a little tougher. Grace, what am I going to have to use to take the derivative for number 5? Quotient rule. Very good. So we'll say f prime of x is x squared plus 1 times the derivative of the top, which is 4, minus high derivative of the bottom, which is just going to be 2x, all over x squared plus 1 squared. There. So you don't necessarily have to simplify, but it'll probably help you a little bit if you do. So if you got 4x squared plus 4 minus 8x squared, and then that'll be, I'm going to do 4 minus 4x squared. over x squared plus 1 squared. So that is our derivative. And so we want to know where this function is either 0, or the derivative is either 0 or undefined. Right? Could this one be undefined? The answer is actually no, but it, like, there's a possibility for it, right? We need to check it because we do have a denominator here. This is a little bit of a trick question. Like, we do need to be concerned about whether or not this one had, the other one there was nothing to check for undefined because you had no denominator. Here we do need to check on it, but it is not going to work out. We're going to see. So if this equals 0, the numerator will equal 0, right? If this is undefined, the denominator will equal 0. So whenever you have a derivative that is a fraction, you want to set your numerator equal to 0. This will check to see where your derivative equals 0. And then you also want to set your denominator equal to 0. And now check for where it's undefined. And so over here we could do 4 equals 4x squared. We could divide by the 4. 1 equals x squared. What do we get there when we square root both sides? Plus or minus 1. So we have two critical points there, positive 1 and negative 1. When you square root both sides, make sure you remember to do the plus or minus. For x squared plus 1 squared, you would square root both sides. So that would give you x squared plus 1 equals 0. You would move the 1 over. That would give you x squared equals negative 1. Then you would try to take the square root, but what happens whenever you try to take the square root? You get an imaginary number, which means that no real number is going to give you a 0 in that denominator. If you think about it, you got x squared, so no matter what number we plug in, we're squaring it, right? So that's going to be a positive number. Even if it's negative or if it's a fraction, it doesn't matter. That's going to be positive. Then we're going to add 1 to it, which will make it even more positive. And then we're going to square it, which will keep it positive, right? So there's no way you could even get a negative number under here, much less 0, unless you used imaginary numbers, which are not real numbers that we have to consider for the domain. So you don't get anything that would actually give you undefined here. So we got x equals plus or minus 1. Are you done? Okay. I'll take it right here, bye. And here are the notes. You can pick up where we're at. Okay. All right. Questions? All right. Extrema on a closed interval, so extrema is maximums or minimums, can only occur at the endpoints of the interval or critical numbers. Okay? So places where your derivative is 0 or undefined. So you can only have these absolute maximum or minimum points either at the endpoints or at those places where you have a critical number. It's not going to happen anywhere else. So your derivative is either 0, undefined, or it's one of the endpoints of the function. So, for the extreme value theorem, this is how we apply it, right? We know because f of x is continuous, the extreme value theorem tells us we've got to have an absolute maximum, we've got to have an absolute minimum. So this asks me to find the absolute extrema of this function on the interval from -2 to 1. So the first thing I want to do is look for critical numbers, because I know I need to check the endpoints of this function, -2 and 1, but I also need to know if there are any critical numbers on that interval that I should consider. So for critical numbers, we're going to take our derivative. So f prime of x is 6x squared plus 6x And then I'm going to set that derivative equal to 0. In this particular case, there's no way that's going to be undefined. So I'm just going to have 6x squared plus 6x equals 0. How do I solve that? Okay, we can pull out a 6x or just the x, whichever one you prefer. We get x plus 1 equals 0. And then we set each one equal to 0. So 6x equals 0, x plus 1 equals 0. We will get x equals 0 and x equals negative 1. Okay, these are what we call our critical numbers, and they are possible maximum or minimum points, or x values where we'll have that. All right. So maybe you might have a maximum or minimum at 0 or negative 1. Do both of those fall in our interval that we're looking at here between negative 2 and 1? They do. So we got to check both of these. So your possible maximum or minimums, so your absolute max or min possibilities is that I or A right there? It's A, right? Possibilities. Possibility. I looked better, didn't it? Well, they don't count for spelling. All right, so your possibilities are f of negative 2. You could have f of negative 1, f of 0, and f of 1. Those are the only places you could have absolute maximum or minimums, either at the critical numbers or at the endpoints. So what you're going to do, you know the function for the original, you're just going to plug in. So you will have 2 times negative 2 to the third plus 3 times negative 2 squared. And for the sake of time on these problems, whenever you get to them on your homework, I do not mind if you use your calculator for this because it can become time consuming, especially on the ones that are a little more intricate. So if you want to use your calculator on this, but these do a lot of times show up on the calculator inactive, but I just don't want it to take us a really long time to do this. So that's going to be negative 8, that's negative 16 plus 12, so you get 4 right here. For negative 1, we'll have 2 times negative 1 cubed plus 3 times negative 1 squared. So that's going to be negative 2 plus 3. I'll get positive 1 there. For 0, I will just get 0. And for 1, oh wait. Yeah. And for 1, I will get 2 times 1 cubed plus 3 times 1 squared, which is going to give me 5. Okay, so then you just have to look which one's highest, which one's lowest. So our absolute maximum, what would our absolute maximum value be? Oh, it should be negative 4. Thank you. That makes a big difference too. Our absolute maximum is 5. It's your y coordinate, right? And I'm going to write over here to the side, occurs at x equals 1. And then your absolute minimum value, what's our absolute minimum? Negative 4. And it occurs at x equals negative 2. So the absolute maximum minimums for this particular problem end up being at your endpoints, right? So if we, let's just look, I think it's helpful to see a picture real quick, and this will be real quick to type in. All right. Let me do that. Hold on. Okay, So if we type that in real quick, here we got 2x to the third plus 3x squared, and then we're only looking from -2 to 1, so -2 less than or equal to x less than or equal to 1. If I graph it, this is what I'm looking at, and you can pretty clearly see that those end points are going to be your highest and your lowest points. But these are typically going to be calculator inactive, so you wouldn't be able to graph those. Let's see.
Do you have to write a separate sentence to say what the maximum and the minimum is, or could you go out next to it and say this one's the maximum and this one?
It would probably be okay to like circle right here and say absolute minimum. I think that would be okay, as long as it's very clear that you've labeled it there. And depending on how they ask for the absolute extrema, meaning they want the maximum and the minimum, so that's the y coordinate. So this is the y coordinate. Sometimes the question may ask for the x coordinate where it occurs, and if that is the case, then it would be important that you include this occurs at. I like doing this every time anyway, in case you just like misread the question and it was wanting that. But this one is asking for the extrema, so if you only put the y coordinates, that would be okay. All right, so 7 says find the global extrema of this particular equation on the interval from -1 to 3. So whenever we're doing these problems, we need to find the derivative first. So derivative f prime of x is going to be 2 minus 3 times 2/3 is going to give me 2. X to the, if I do 2/3 minus 1, it's going to give me -1/3. So it's probably going to help me a little bit to write this way, 2 minus 2 over the cube root of x. So for this particular problem, and actually let me write it like this, I'll make that 2 minus. So for this particular problem, I can tell right now what value is going to make this undefined. What value would make this undefined? What would give me a 0 in denominator? Just a 0, right? There. So 0 is going to give me a 0 in the denominator. However, I can't just like set a numerator equal to 0 here. So it's up to you. You could either go ahead and get common denominators for this, or you could set the whole thing equal to 0. Either one will work here. So I know that x equals 0 is going to be a critical point. To get the other, I would have to do 2 minus 2 over the cube root of x equals 0. And if I move this over to the other side, I'll get 2 equals 2 over the cube root of x. What would I do from there? Can I solve for a variable when it's in the denominator? I cannot. So I could multiply both sides by the cube root of x. And that will give me 2 cube root of x equals 2. Divide by 2. The cube root of x is going to equal 1. I would have to cube both sides, so x equals 1. And in this particular case, you could probably just like think about what number would give you 0 there, right? 2 minus 2 over 1 would be 0. You're doing 3 times the 2/3. No. No. This is, because inside of those parentheses, there is not any variables there. So, this is just a power rule here. All right, so critical points are possible, but you also have x equals -1 and x equals 3. So you've got to test -1, 0, 1, and 3 to see which one's highest, which one's lowest. So, a couple of these I'm going to, I'm going to do them all by hand here. For these, you do need to be able to deal with this by hand. So we've got 2 times -1 minus 3 times -1 to the 2/3. I know that's going to be -2. What is -1 to the 2/3? How do I think about that? Let's think about it like a root. This would be the cube root of -1 squared. What is -1 squared? +1. And then the cube root of +1 would be +1. So this is going to be -2 minus 3, which will give us -5. F of 0 is easier. What are we going to get if we plug in 0? 0. And if it's easy to plug in, you don't have to write it out. If this is free response, you can just put f of 0 equals 0. I think technically you could put f of -1 equals -5 if you can do that in your head. But, be careful if you do that. Here I have 2 times 1 minus 3 times 1 to the 2/3. What is 1 to the 2/3? It's just 1, right? 1 to any power is 1. So that is going to give you 2 minus 3, so you'll get -1 there. And then we've got f of 3. 2 times 3 minus 3 times 3 to the 2/3. So we're going to have 6 minus 3. And this is going to be cube root of 3 squared, which is going to be 6 minus 3 times the cube root of 9. Do we know the cube root of 9? We do not. We do know the cube root of 8. What's the cube root of 8? 2. So this is a little bit bigger than 2, right? So you may have this on calculator inactive sometimes. It's a little bit bigger than 2, which means 3 times this number that's a little bit bigger than 2. Are we going to get a positive or a negative answer? We're going to get a negative. Because this is, so estimate, like if you could estimate, right? You could say this is 3 times the cube root of, like the next cube root up would be what? 16, the 16 of cube root? No, 16 of the fourth root. It'd be 27, right? So this is going to be like a pretty small number here if we're trying to do this without a calculator. So we could call this like 2.1. If you do this, if you write this down, it's better to do it in your head. If you write it down, make sure you got squiggly equal signs because this is not equal this. Which means you would have about 6 minus 6.3, which would give you about -0.3. Now that is a really rough estimate. But it doesn't really matter because I know this is going to be negative. So it is smaller than 0. Right? 0 is going to be your highest number. I feel pretty confident it's not going to be more negative than -5. Right? So they might give you something like this without a calculator where you don't know the exact value, but you should be able to come up with an estimate you're pretty confident in so that you know it is either for sure the highest, for sure the lowest, or for sure not either one. Okay? So we could say that this is our absolute maximum, and it occurs at x equals 0. It seems weird for your maximum to be 0, but it is the case. Your maximum is 0 here because all the other numbers are negative. And then this -5 is our lowest y value that we have, so this would be our absolute minimum, which occurs at x equals -1. Okay, questions? Okay, absolute extrema of 2 sine x plus 1 on the interval from 0 to 2 pi. Okay, which is basically unit circle values, right? So, we have to have critical values. We got f prime of x. Derivative of sine is cosine, so we're going to get 2 cosine x. Derivative of 1 is 0. It's going to go away. So we want to know where this is 0 or undefined. Is cosine ever undefined? It is not, so we're just going to have 2 cosine x equals 0. If we divide off that 2, we got cosine x equals 0. And then if we're thinking about our unit circle, cosine is our x value. So where does cosine equal 0? Pi over 2 and 3 pi over 2. So we would need to check the endpoints and pi over 2 and 3 pi over 2. So we would do f of 0, which would be 2 sine of 0 plus 1. What is sine of 0? Sine is your y coordinate. 0 is right here. It's 0. So that's 2 times 0 plus 1 will give you 1. We would have f of pi over 2. So 2 sine of pi over 2 plus 1. Sine of pi over 2, y coordinate right here, it's 1. So 2 times 1 plus 1, that's going to give you 3. We would have to check 3 pi over 2. That's going to be 2 sine of pi over 2 plus 1. Sine of 3 pi over 2. 3 pi over 2 is right here. Sine is the y coordinate. It's -1 plus 1. That's going to give you -1. And then f of 2 pi is going to be 2 sine of 2 pi plus 1. That's the same as 0 there, so we'll have 2 times 0 plus 1, which will give us 1. So our absolute max is, and it occurs at x equals pi over 2, and then our lowest value is -1. So this would be our absolute minimum. And it occurs at x equals 3 pi over 2. And trig functions, most trig functions have to be restricted to a domain for you to talk about absolute maximum minimums because they're going to be repetitive. They're going, well, I guess you could talk about it in a weird sort of way, but sine is going to have infinite maximum points there. Okay, questions? All right, let's see. Let me think real quick. We probably need to do this one. All right, so we need to do a derivative here for our critical points. So I've got derivative of sine is cosine, so that's going to be 2 cosine of x. And then I've got derivative of cosine 2x. So derivative of cosine is negative sine, which just means I'm going to get positive sine. We leave this inside part the same. It stays 2x. But then what do we have to multiply by? Derivative of the inside, which is the 2. So let's put the 2 right here. All right, so this is going to require a little trig memory. We did do these, but we did not do them very much. There is an identity for sine of 2x. Anybody remember it? Let me add this to a formula sheet. It is 2 sine x cosine x. So sine of 2x equals 2 sine x cosine x. So that is a trig identity there. And so when we set this equal to 0, we can write it as 2 cosine x plus 2 sine x cosine x. Set that equal to 0. What can I do after that? You're right, thank you. It will be 4. Because of that 2 that's already out there. If you do, you're going to lose some answers there. Because if you divide by 2 cosine x, it will cause you to lose some answers. But what you can do is you can factor out 2 cosine x. So if you find yourself like wanting to divide something off to get rid of it like that, try factoring it out instead, because it causes you to lose some answers. So if we factor that out, we'll get 1 plus 2 sine x equals 0. And so now we can set each one of these equal to 0. So we would have 2 cosine x equals 0, which means cosine x would equal 0. From 0 to 2 pi, where does cosine x equal 0? Pi over 2 and 3 pi over 2. So we got those two critical values. For 1 plus 2 sine x equals 0, we'll subtract the 1. We'll divide by 2. So sine of x will equal negative 1/2. Oh, that's a little harder. Unit circle. So like right here, it's pi over 6. Right, that's square root of 3 over 2. Positive 1/2. But we need negative 1/2, which is going to be like right here and right here. 7 pi over 6 and 11 pi over 6. So, we need to be able to do this by hand. But I also know that we don't have time to check all of those today, and you guys don't have time to check all those at home either. So, let me show you what you can do. I will let you use your calculator. Watch this. I'm going to go to y equals. And I'm going to tell it, I'm going to put the original function in y equals. I do not want you using your calculator to take the derivative. Please do that by hand. And please set this equal to 0 and solve by hand if you can, and you should be able to on everything. But for the plugging back in, it's for the sake of time, not because we shouldn't be able to do this by hand, that I'm going to let us use the calculator. So I'm going to put 2 sine x minus cosine 2x into my calculator. Right here. I'm putting it into y equals because this is going to make it super fast for me to find the answers here. So if I put this into y equals and go back to my main screen, I can now, instead of having to type in the whole equation, I can type in y1 of 0. And that is going to be -1. So I can write that down. Actually, don't use calculator notation. So you don't want to put y1 of 0 right there. I was about to write that. Don't do that. You want to use your function notation they gave you. So f of 0 equals -1. And then the cool thing about having it in the calculator is my next critical point would be pi over 2. So I could just do y1 of pi over 2. And I'll get 3. So f of pi over 2 equals 3. And then you don't even have to do them in order. I could go ahead and do 3 pi over 2, even though 7 pi over 6 would come before that. It doesn't matter. So y1 of 3 pi over 2 is going to give us -1. I've got f of 7 pi over 6. y1 of 7 pi over 6. And I got -3/2, or -1.5. I've got 11 pi over 6. y1 of 11 pi over 6 is going to give me another -3 over 2. And then 2 pi. So y1 of 2 pi gives me -1. Alright, so for this, my highest value that I see right here is 3. So that's my absolute maximum. Occurs at x equals pi over 2. My minimum actually shows up twice here, right? That -3 over 2 is my minimum. So these right here, -3 over 2, this is my absolute minimum. And it occurs at x equals 7 pi over 6 and 11 pi over 6. Okay, so I do not mind if you use your calculator to plug these back in. Let me see. All right, extreme value theorem guaranteeing. What are you concerned with here? What does the extreme value theorem, what's its condition? What does it tell us has to be true? Your function has to be continuous, right? So you would look to see which one of these is continuous on the interval, and there's going to be some of those that are not. We don't have time to go through the whole thing. This asks you to make some conclusions. We may look at these at the beginning of class, like as a warm up tomorrow, or maybe not. I don't know if we got time. Okay, so your assignment for tonight, 7 through 10 is just looking. It's just looking at graphs, so it should be really fast. Then you have 21 through 31 odd, 35, 41, 43, 75, 74 through 76. You may use your calculator to plug the numbers back in. Try to do the derivatives by hand, but you may use the calculator to plug your numbers back in because it can become a little bit tedious on some of them.